Okay, so I thought we'd just quickly get started by knowing actually who's in here. How many of you are here from like a programming background? Okay. How many of you are here from a stats background? Okay, a few, that's good. It's good to see, like, you know, who I'm going to offend and so on before we start. How many of you are from pharma and from CRO? It's good. It's quite a good even like mix kind of thing. Again, the reason for asking these things is because we all look at things depending on where you're coming from, what you're trying to do. Your end goal is different. So today I want to talk to you about step-by-step approach to AI. But actually, before we get to AI, you start off with automation. As Thomas was saying, I started programming a long time ago. Let's just say this. I think my first proper job was 29 years ago today. Was my first day. So it's a while, and I always hate manual stuff. It doesn't matter what manual stuff it is. I think, you know, if we can automate things, then you can go on and do more interesting things, right? Everyone wants to do more interesting stuff, but the basic thing still needs to get done. My automation kind of thing started very early. I might even be challenging Richard here. I did my first automation in 87, 88. I'm not even sure how many of you were born then. But it's a while ago, 1987, 88, in case you're wondering. My dad used to own a restaurant, right? And so what I thought was actually, you know, because I used to see all these, so it was an Indian restaurant, and I used to see all these Chinese restaurants which had numbers. And Indian restaurants generally, they did, but no one really considered them numbers. It was just kind of, you always ordered by what you wanted. Whereas when you went to Chinese, you say, oh, I'll have number 4, number 10, and whatever. So I thought actually in Indian restaurants, when you have parties and stuff, what if you just also, you have a menu, you can put in numbers, and then it adds to your bill, and it prints something out in the kitchen so they know what to bring out, right? It's great. So that I did in 1988, my first automation thing, because I thought actually, then it's like, you know, the waiters can spend more time to bring the stuff quickly and so on. The kitchen staff can start making stuff. People ordering, right? They're directly communicating with the chef in the kitchen. So that's kind of where that started. So it's just a brief history of me. I've been programming, like I said, for almost 30 years. I've worked in pharma and CROs. I've worked in Germany, Holland, and I'm usually based in London, so it's a quick underground trip today. So what I want to talk about today is really the role of like AI automation, and it's a step-by-step process, right? And you can't just jump into things like AI without having automation, or can you? Right? I posted something recently on LinkedIn, which was like, for example, I think it was Nietzsche. He said you can't like fly into flight, right? You have to learn to stand and walk first before you can fly. But then, what I posed was in Bangladesh, if you were in the past, you're waiting for your landline, you could be waiting like decades unless you've paid the right bribe and so on. But also if you're in rural part, you're just not getting it, right? But then now you have mobile phones, and then they didn't need to get like landline anymore. Everyone could have a mobile phone. And then when I was there last time, there's people in the villages, right? They were doing their crops based on an app on a mobile phone. These people can't read or write. But here they are, there's an app telling them when to go and plant and when to go and water and all these things. And they were following this, and they were doing really well. So it's not that everything has to be step by step, and not necessarily you have to do automation and then go on that. It helps. So what I thought is today I'll just have a quick look at what we are currently doing in stats programming. where is AI in stats, right? We're all doing stuff. We're all in pharma, we're in stats, we're in programming, we're in CROs, but how much of it actually, is AI impacting us? How much are we using AI? And what are the benefits of using AI going forward? So, you should think about that. Actually, before I go there, I did a little bit of research for this presentation. It's not like by chance. And being in the industry for such a long time, I know like people across the board. And I asked everyone, like, where are we with AI? What are you guys doing? What are you guys doing? And so on. So, clinical people, you have like, they're going to conferences and they have this AI tool, which they get all these leaflets from the conferences. They just chuck them in and it gives them a like quick one-page summary of what were the big topics that was discussed at the conference. So, in the past, we all came home with big bags full of leaflets, right? Or you've got all these like, LinkedIn things, or you've got like, okay, these days, like, links to websites and so on. But you always still have to read it, right? So what these people were doing was they're like, we don't bother with that anymore. We shove it in this AI tool and it gives us a one-page summary of what that whole conference was about. So they're putting in like hundreds of pages and getting a quick summary, right? I think some of you are also doing these things with emails and stuff, I don't know about you, but if you get a really long email, you're like, the email which has like 3 lines, you're going to read that. But the one which has like, 3 paragraphs, you're like, oh, later, right? So people are using AI in all sorts of different ways. But in stats programming, it's like no one. Everyone's like, yeah, well, we're thinking about it, but actually, no one's really doing much. There are other things where, we have people like statisticians looking at, see how you can summarize like protocol. You've got people trying to get the key things out of SAP so that we can try to see if we can automate like, tables and all these things and so on. But you can also think of it going forward, like, well, actually SAP has to be written by someone, right? So why don't you get the key information first and then feed that to all the different things? So there are different ways we can kind of go forward. We don't necessarily need to start with protocol and all these things. Okay, so if we look at our standard data flow, right, hopefully you can read it. Also, like sometimes, when you have a screen, they show different colors to the color that you see on your laptop. Anyway, the basic part here is you've got your protocol, you've got your CRF data, eCRF. You then create your SDTMs, and again, that's like whether C- or raw data, doesn't matter. You've got your SDTMs, then you've got your Adams, then you've got your TFLs. Actually, after you've got from your protocol, you also have your SAP, right? And there you create your table of contents, you've got your table shells. Again, I was asking around, how much time do we actually spend on like table of contents and to create table shells and so on? And it varied, right? Some people were spending 6 weeks, some like 8 weeks, 12 weeks, because that's not just for one person, that's like total, because if you have a whole load of people reviewing stuff. This is all time, right? And if we think about where does stats programming come in? Well, actually, we do provide input into SAP. We do provide input into shells, mainly to say, actually, this is not quite correct. Right? The statistician gives you a thing, you review it, you say, yeah, no, you've missed this or you've missed that. And then you start programming, and then you find more issues that's not clarified in the SAP, so you go back. So actually, we're involved in all these things. So why don't we look at actually where do we start from? Where do we get involved? How can we make things better? So as I say, the current process is you do your study setup, right? You identify your Adam data set that you need to create. You've got the standard ones that you must create. And then you've got the ones that actually, these are study-specific endpoints that you need to derive. Then you go away and you program your Adam data sets. They're all time-consuming stuff. Once you've got your Adam, then you start programming your TFLs. Then you go back and you correct your Adams. Then you go back, you correct your specification. And at the end, you produce like your final output, and then that's sent off to the medical writers. So this is kind of standard process, and I think it's kind of across the board. Generally, this is what's happening. So you've got all these different functions involved. So now the question is, where are we with AI and stats programming? As I said, it's pretty much ChatGPT, someone writing, can you create me an A summary table and things like this. And I've asked people like in the US, in like India, China, across Europe, there really isn't any AI that's actually being used in a systematic way. Right? It's very much a little bit like, R has taken a long time to kind of become a little bit more prominent. I remember 20 years ago, R was going to be quick. It's going to overtake everything, right? Then it was 15 years ago. It's almost there. And I think we have like one pharma company which has kind of moved everything to R and so on. But again, we don't need to think of everything as like all in one basket, right? Everything is a transition. Okay, pharma is more like a tanker. It kind of moves very, very slowly. Just to give you an example, I did my placement year, right, in 1993. So this is where you spend 1 year in industry, working at a company after 2 years of degree, and then you go back and you finish your final year. So that was in 93. So just to say, the stuff that I produced then are exactly the same stuff that we're producing now. How sad is that? Right? It is just like really depressing. I don't want you guys, right? I can see some fresh young faces. I don't want you guys to be in my situation in like 25 years' time, saying we're doing the same stuff that we did 25 years ago. That would be just depressing, right? So we need to make sure, and guys, you are the ones who are drivers, right? You need to go back, you need to speak to your bosses and get them to adopt. No one wants it, right? Everyone, especially pharma, everyone thinks, oh, it's change, I'm going to move from this job in 2 years' time. I don't want to rock the boat. But actually, like I say, it's like a ship. It's no longer a boat, right? We're just moving so slowly. If you think of our trial reports, it's a glorified printed paper, right? We're doing PDFs now, electronic submission, glorified PDF, glorified printed paper. We need to be able to move forward, right? You see like in adverts, you see all these scientists with their 3D goggles on, walking through molecules. We look at a PDF file. Whoa, look at that graph. It's not even like moving, right? The graph is just a fixed graph. At least make it more interesting. Make it like, if you're a statistician, you're presenting, make it animated. So that actually is a bit more interest, but actually not just that, it gives more information, right? Make it so that we learn more. If you have an animated graph, it's showing over time what's happening or whatever. It's showing more details, right? It's not just a fixing, here is what it looks like at the end. Show us what it looked like at the beginning and how it progressed. Then people can see how things have changed, and that encourages, that motivates people. Look, if we've come this far, we can actually go further. But if you just see the end result, it's like, yeah, that's where we are, okay. There's no enthusiasm. So we need to try to see, as I say, we need the programmers to speak to your bosses, say, look, we need to look at AI, or we need to look at automation. How many of you have some kind of automated system which creates programs for you? Seriously? No one? You know, like for example, your TLF programs, right? Your basic stuff. How many of you have a system which then just creates your program for you? You put in some metadata and then it writes a program for you. Okay, here we go. See, a few. So, but there's still a lot of people where it's not happening. We should be doing this. That should have already happened, right, a long time ago. I remember, like, not when I started, but perhaps about 25 years ago, like 4 or 5 years after I started, made a client where we then wrote some macros which produce outputs, like, you know, the TLFs, and especially with things like listings. So wrote like patient-specific footnotes. If there were, like, you know, patients which had certain quirks in the data, and you wanted to put that like quirk in the footnote of a listing, you didn't want that on every page, right? You wanted it just on the pages where that patient number appeared. So I wrote a little macro system which then did this. So they produced all their listings, and only on pages where those patient appeared, then there was that footnote telling them about that specific issue. But that was, again, like automated system, right? And I want us to move towards that. I still see a lot of programmers. They're just copying programs, right? A lot of companies, well, actually most companies have standard macros, right? Is there anyone here who doesn't have standard macros? Right, everyone has standard macros. But I think, as we discussed earlier, most people are still double programming, right? Validation, right? Why? We don't trust the programs? But the thing is, it's not just the programs. When we're double programming, I was having a discussion earlier, what you're really doing is you're checking that the programmer has understood what was mentioned in the specification. Not that he can't program what was mentioned in the specification, but that he understood it. So then when you have a second person, they're double programming. Did they understand the same thing? You know, like, for example, I don't know, okay, in the UK we have English. I'm sure you'll have, like, you know, if you're from other countries, in your school, you've studied, right? You've done English Shakespeare, and everyone has to write, what did the poet mean when he wrote this? And everyone has their different ideas. Sometimes SAPs are like this, right? Sometimes some of the specifications for TFLs, Adams, are like this. And you look at different people and they understand completely different. And it's just because someone's put a comma in a different place. And so then one person thinks it's this, or someone's written or in a different place. So when we double program, what we're doing is not just checking that they could program what was written in this thing, is that they've understood what the person who's written that specification, right? They've understood what they meant. And so then if you have two people, the chance of both of them misunderstanding are actually, or both of them understanding the same thing, are high. So then if they've both understood the same thing and it's different from the person who wrote it, then you know there's something going on. Or if there's something where you've got two people and they've understand different things from the same specification, then you know the specification has to be rewritten, and that's how you catch the stuff. So most of the time, for basic things like TFLs and so on, you don't really find too many issues with double programming. But what you are doing is really trying to find actually was there a difference in understanding. And especially things like Adam programming, that's where big things happen, right? You've got endpoints, people understand different things. So it's really understanding the English rather than being able to translate that to code. That's what we're checking. Now we have, like, you know, a lot of systems around which can do this, like natural language, right? They can produce specifications. They can understand the natural language and produce code. So why aren't we doing these things? Now, partly is, if you think about it, like you all said, you've got standard macros. What you don't want to have is you don't want an AI system writing different code for the same kind of program, right? Because then you're back to square one, back to like what it was 25 years ago when we didn't have macros and every program looked different. And when you want to update something, you're looking at it and you're looking at full length of code again. Whereas now you just look at a shell macro call and you say, actually, oh, okay, I want to change, have median and things like that. So there's a lot of scope here for AI to get involved, to help us to translate from actually SDTM, from SAP to TOC. So what I think is, if we look at our process again, right, this part here, this SAP, the TOC, the shells is an interesting one, right? So most companies have standard shells. Right? I remember, like I said, about 29 years ago, one of the clients from the company I was working at, they had standard shells. Right? And then it was already, like I say, it was already available there. We wrote programs which produce those shells and so on. But from the company standard shells to shells for your specific trial, you then still spend weeks producing it, reviewing it, correcting it. And what I want us to do is I want us to think about, how do we get away from them? Why are we doing that? You have a standard shell, whether you produce the output in-house or you give it to CRO, you kind of expect that whoever's programming should be able to understand it and produce it. So why are we creating study-specific shells and then for each thing? Because you have already in your standard shell somewhere it says, replace this with your treatments and so on, right? We have ADAM data sets. We have ADSL, which tells you what the treatments are. Why are we not using all these things? So there's a lot of scope here. But as I say, with AI, we want to get to automation first, because it helps us with our thought process, right? We're in this thing of let's stand up and walk before we try to run and fly. So if we automate stuff, then we understand what are the intricacies. Because how many of you have written a macro? Right? Yep, to everyone. So you've written your macro and you've tested it on your one thing. Oh, it's working beautiful, right? You give it to someone else. Oh, actually, it's not working for my data. How many of you had that? Yeah, right. And that's the thing. Everything, it's not always perfect the first time, right? And then when the second person runs it, they ask questions. So then you build that into your macro again, right? You update it and you say, actually, but then what it does, it teaches you that actually, oh, I need to also consider this and this. And that's why when we're talking about AI, you have to be careful about jumping straight in, because if you didn't create that macro, you wouldn't have thought that actually you also need to consider this other thing which you didn't consider before. Because we all have limited knowledge, right? Insight into what we're doing, right? What we produce is based on our background, is based on what we have done previously. So when you then have like 10 other people, I think we talked about open source earlier. So whether it's open source or even just like a SAS macro or anything, you write a macro, give it to everyone else in your company, let them all play with it and tell you all the problems there are. Don't take this personally. This is just work, right? This is how we get better, by sharing what we're doing. And it saves them time. And then actually, they will also give you ideas. They'll say, oh, actually, if you also do this, then we can also use it here and here. And then I'm sure, I think like most of your companies, they'll have like a process of escalation, right? So you start off with like a basic macro that you've done for a trial, and then you give it to 10 other people. They're like, oh, actually, this is quite good. Actually, we use it in the project. And actually, can we make this a company standard one? All it generally means that you have another 3 weeks of writing documentation. But that's just, you want to make sure it's good. And something I always tell people, documentation. How many of you read like I can see most of you have smartwatches and so on. Like, how many of you read the user manual? right? No one reads these things. Sorry, Christian. Right? No one reads user manuals unless something's gone wrong, right? That's when you look, it's like, why is it doing that? I'm not expecting that, right? So same thing with like documentation, whether you're documenting in a program, in a macro, or writing a separate user manual for a macro that you've written. Remember this, people are only looking at that when something goes wrong and they're not sure what they're expecting, right? So avoid writing essays. No one reads essays. You have a 2-line comment, people are going to read that. You have a 10-line explanation, no one is reading that, right? So keep that in mind when you're programming. But as I say, automation, we need to make sure we take these small steps, and as we move forward, then we can then make life easier, make life better, and share. As we share stuff, then we can then understand what are the things that we need to take into account when we want to move towards AI. Because, again, I'm not sure how many of you have come across this, where someone says, we've got output, it's working. It's like, no, have you looked at the numbers? Doesn't make sense, right? And AI is similar. It'll give you something, right? You have to be careful that you understand actually what it's giving you. So just like, oh, we have output, so the macro is working, or like what Richard was showing earlier with like SAS and R programs that interpreting things differently. And in a world where we're using more software now, we're using SAS, R, Python, you need to be comfortable that what you've produced, you've understood, right? So you have to be careful about just jumping into AI without automation, because then you're missing out all the steps, all the problems that you could have, you would have noticed, but now you just got some output and you're not quite sure how much of it to trust. I think with Verizion, I think where they've got these like, scale of actually how much you can trust, that's quite a good idea. But again, if it's not great, then you have to look at it again, So it's important that we understand. And like I say, automation is a step towards understanding what are the problems that you might face when you produce your output. So how can we leverage AI? Something to be aware of, like, we want to make sure things are consistent, right? We want to make sure there's traceability, there's quality at the end. When I say consistent, what I mean is, as I said earlier with regards to program, if you're auto-generating a program, you want to make sure it's the same each time, or it's giving you the same result, right? You want to make sure that if you've got 5 different studies and you're producing the same table, you're using same code. If you've got different looking code each time, whoever's reviewing it is going to have to each time understand what's going on, right? But if you've got like a macro call, then people are just looking at that. So they're like, oh yeah, I've seen that macro, the macro call. Yep. So here I'm just checking these parameters. Yes, that's fine. So it makes life easier. So we want to do things consistently across studies. Traceability. Traceability is not just about the program, right? It's also about the data. What's happening with the data? How is that changing? If you are changing programs, right? If you've got multiple programmers in a study and you go and you update a program later, can you go back? Again, the number of times when I've programmed something and then they come back, no, we need to change it to this. And then 2 days later, can we go back to what you had 2 days earlier, right? So you need to be able to go back. You need to be able to see what changes you've made. Sometimes, like after something's been validated, the rule has changed. So then you implement the change, and you need to be able to go back and see any results that you've already published based on the old one. You need to be able to see what the rule was, what the change was. And as I said, quality. Something here I've got here: reduce, reuse, recycle. I was driving to Germany once, and because of snows like started falling and stuff. It ended up being a 17-hour journey. My son at the back was watching Bob the Builder, and that's all I heard: reduce, reuse, recycle for like 17 hours. And it was just like, but that's what we need to do here, right? We need to reduce like the number of individual programs and macros that we're using. I was talking to one client, they have like over 100 standard company macros. They have no idea how many people use them in the last year, because they're not actually keeping that anywhere. They're not documenting it. So, and they're spending a fortune, both in time, effort, resources, everything else, to make more macros. Right? Sometimes because someone thinks, it's a great idea to have this. But actually, you need to also do the selling part that the rest of the company uses it afterwards. Otherwise, you have these big macros, which are kind of like black box. So we need to make sure that they're modular, that people can use them, they're small enough for people to understand things, right? Then they can reuse them, sometimes in different places. You might have created a macro for one thing, and then actually someone else finds a use for it in somewhere else. Yeah. So if you make it small, then things become reusable. If it's small, then people find it easier to understand. So what we need to do is we need to make sure that we reduce some of these big things, right? We reuse existing macros and so on, and recycle. What I mean by that is, again, code, using it for different purpose. It's built for one thing, use it somewhere else. Okay, so this is where I'm thinking AI is going to come in, right? You put in for a particular study, you say, actually, this study is like it's for diabetes, this endpoint, it's a phase 3 trial, we're looking into this and this. And, we've all done, right, hundreds of these studies before. So if we feed that information into an LLM, then it can tell you, actually, your talk should look like this. These are the outputs that you need to produce for this study, right? And this is, with the information we have, you can get this about 90–95% correct. Right? It's not going to be 100%, don't expect that. But what it will allow you to do is you allow the statistician and so on to look at this and say, actually, okay, yep, for this particular study, I also need X, Y, and Z. Actually, yep, no, everything else is fine. But it allows you to do that, so it speeds up the whole process. And of course, these are stuff that you've already done before, right? So you also have shells for them, right? You also have programs for them. So if we then think of what we can do with that, right? So for each output, right, actually, here's the shell program which produced a macro call which produced that output. Actually, you use these Adam data sets, and then it used these macros and so on. So actually, for these Adams, actually we needed these endpoints were derived. So you can then say, actually, know what endpoints you need. Actually, these endpoints, we already have macros which creates these endpoints. So let's put those macro calls already in our template program, Adam template program. So, and they're using these SCTM data sets, right? So what you can do is you can then say, almost kind of going backwards. So from the protocol, from the type thing, you need to create this whole list of tables, right? And these tables you've produced, the ones you've produced before, you can then go backwards. Actually, I need this, this, and this. And what it means is that you end up with like 80% programs. Adam is not going to be 80%. You'll be lucky if it's 50% at best, right? But over time, when you think of like all your studies going in here, it's reading those code. So then over time, you can aim to get 80% of your Adam programs done. Like I said, never expect 100%, it's just not realistic. If you're lucky, I mean, I used two macros to produce like some standard tables. I used the same ones for like 18 years. And for all these different studies, it worked. It's great, right? But in this, like here, you're not going to get that too much. but your TFLs, your Adams, you can get most of it done here. And what it does is it saves time, it saves effort. You're reusing stuff, so it gives you consistency across trials. You're not going to be deriving one endpoint differently from from the same endpoint in a different study. If you want to change it, you can then do, right? You have the option because you're looking at the code, but it gives you the starting point. You're not starting at 0, you're starting at halfway up already. So, as I say, the benefit is that you end up with about 80% of your programming efforts taken care of, right? You're streamlining your reporting process. I used to have programmers tell me, it's like, Shafi, are you trying to get rid of our job? It's like, no, but you don't want to program another demography table, right? You don't want to program another AE table. You want to do some more exciting programming. And the statisticians and so on, they also want to do exciting analysis. But they can't do those because we have no time, because we've got to do this stupid demography table, right? So if you get rid of all the mundane stuff, automate this, right? These are all produced automatically. So we generate like most of the standard TFLs, we auto-generate the programs. And we use our standard shell macros, and so then we don't need to program them. It means that programmers have more time to spend on more exciting stuff. Right? They're not doing this stuff. So it gives them a little bit more. And as we have more studies going into the system, then actually it gets better and better. So, plan, step-by-step approach, right? Let's plan what you want to do. What are the studies that you need going in? Really look from top down, right? Start at the top. What do I need in this project? This, and this. And then let AI drive some of that. Automation drive that based on what you've already done. You'll have different company standards. You don't want ChatGPT writing your program. You want a program which looks like something else that's done in your company, because that's reusing and reusing your standards and so on. So actually, let's plan that from the top. Bring that down. Automate that system. As I said, develop. Use macros to automate a lot of the endpoint derivation, a lot of the TFLs. Test it, right? As each study, put them all into a big pool. And then for all your different therapeutic areas and so on, perhaps add that as a parameter in your macro call. Can help with automation. And then later it can help with AI. When you can say it's this type of study, it then already generates the macro calls automatically. An important thing is after launching, then optimize. Get everyone trained and then reuse them. The more you use them, the better it gets. And for me, that's really automation leading to AI. And that way, we should be able to save about 80% of our programming time overall. But that's at the end, 50% to start with, but 80% overall, that's our goal. And I think that's a realistic thing. Thank you. Any questions? No questions. Yep. So.
It seems to be, as per your talk, innovation averse space, not too many innovation happening. You'd love to see more. I was wondering if you also get pushback from any sponsors potentially on using any of these innovative measures.
Actually, the question is, do we get any pushback on using some of these measures? There's actually two parts to this. Where we do the programming ourselves on our server, there we have kind of full control, and clients like the programs because actually it doesn't matter where the programmer is sitting, the program always looks the same because it's auto-generated, right? And the clients like it because it's consistent. So in all the different studies, the programs look the same. Where it's actually things are done on the client server, there you can't use all these tools, right? So, and that's where we try to get clients to, whether it's our tool or their tool. It's good to get them to have automation, because until they adopt it and until they try to kind of push it forward, if they leave it to you can do it if you like, but you don't have to. Everyone just, I've got a program from the last study, I'll just take that and I'll just update it, right? That is our mentality. And we need leaders, we need the heads of programming groups and so on to say, no, use this new thing so that to drive the automation, so that actually this whole team, companies have like whole teams which are developing macros. And then if people aren't using it, it's like, come on, what's the point, right? And the number of, I don't know if like all the different companies here, if you've kind of keep metrics on how many of your program macros are actually being used, because often that information is not even collected. So you think, yeah, this is a really useful macro, everyone will use it. And then you find everyone just copying the program they produced 20 years ago and just adapting it, and everyone's bypassing your macro. So it's important that the sponsors lead, and especially, like I said, the pharma companies, they need to adopt some of these things. They need to be open, and also they need to understand it saves them time, right? For CRO, it's actually, well, not great, because you want to spend more time because you're billable. For pharma companies, sometimes what I see is that it's decisions being made somewhere away, and so the people that we're in touch with, they're not really that bothered in terms of like time. So there isn't the incentive to speed things up and so on. And I know that might sound harsh, but I get that feeling sometimes that actually, come on, if you do it this way, you can save so much more time in all your trials, not just one.
And as one follow-up, just curious, is there a particular type of sponsor, so the flip of the question, like who this approach particularly resonates with, who see the value in this and see that there's a great benefit?
Generally, the smaller pharma companies and so on, they're like more adapt to trying out new things. Biotech companies where they're using the same company to do because usually biotechs go with the pharma, with the stats and programming and so on. So there, if you say, actually, okay, look, can we try this? And then they've got a few things in their pipeline, and they'll say, okay, because in the first round, you're not going to make much savings, right? It's the second, third trial where you then suddenly you've reduce your time, really significantly. So, but the big pharma, they're really, in terms of trying to get them to go, turn the ship around, it's very hard. Yep.
You mentioned that you use clinical trial documents to train the models. What about clinical trial data? Did you also use that already? And if yes, what about data privacy?
So the question is that we use clinical trial models to train the thing, and what about clinical trial data and data privacy? Actually, we have not started with the AI part yet. So that's where we think we want to go. That's where we want to do it. And one of the questions is about this data privacy, because we want to get client buy-in before we start doing that. So because of that, we haven't done that yet. So we've got the automation part, but actually the data, you need to get the client to say, yes, you can use AI on this thing. And then, so we haven't done that yet. But where we're trying to do is see how far we can go with automation. Because if you say actually this, and this, then, and where we don't, because we don't do stats, we just do programming side of things. So then we need the client buy-in so that they can create the talk and so on. So that's where we are trying to see if we can get someone to buy in on that one.
One question. Do you maintain a macro that if I have a macro, give it to you, I don't have a specification, I don't have nothing, I just toss it at you, and then both work out how to get that proper sorted, because it was written in a rush. However, it's doing what is expected to be. So how about that?
The question is, if we get a macro that wasn't properly documented and sent to us, and like, how do we keep that, and how would we use that? Generally, so there's actually two parts to this. One part is sometimes we get given the macros like, please use, here's a compiled macro, and it's pretty much a black box. And then we get a document to say, actually, these are the parameters and this is what it means. But the other one is actually, here's a macro we've written, it's not great. So what then we do is we then actually adopt it, and then we update it. So we make sure there's documentation, because for us, and generally then these remain client specific, but we always document it, because not just for the client, but also for our staff, right? We want to make sure that actually everyone understands the macro. Is again, they're only looking at that when they get in trouble. So we want to make sure that actually there's some kind of documentation available. Yeah, so we take care of that.
One final quick question from live stream. Do you have any specific tools on how to automate SAS programming that you would recommend?
Well, this wasn't really about the marketing thing, but yeah, we have our own analytics system where we automate the programs. We auto-generate all the programs. So you give the metadata to say, actually, you want to produce this table, or you want to summarize, like, you know, this, and this in this way, and then it then auto-generates the programs for you. But I'm not actually too aware of many other automated systems like this where it auto-generates the programs. There are some client-specific ones, but they don't really auto-generate the program. They just kind of hold the metadata. You still have to create the program yourself. But yeah, we auto-generate the program, and that way you get consistency. Yeah.
Thank you, Shadi.
Okay. Thank you.